Hey, GED students. So student Robin had a question about one of the practice problems on the advanced level practice for finding the area of composite shapes. And this was a doozy of a nasty problem. Rude. Let's go ahead and take a look. Probably, by the way, guys, a little harder than what you might see on the GED, but certainly involves a lot of the same reasoning skills that you're going to need when you do area and perimeter of composite shapes. Let's take a look. The Fitzsimmons have approached a contractor to give them an estimate about some proposed improvements to their backyard. After chatting with the Fitzsimmons about their ideas, he draws up a draft of what their yard could look like with the following improvements: a 6-foot tall fence around the property, a garden area surrounded with a wire fence to keep the dog out, a cement slab with built-in pool and circular hot tub. Ooh, I'm jealous of the Fitzsimmons. And 5 elm trees planted near the back fence. The elm trees are to be planted within 5 circular areas. Okay, awesome. And we can totally see that here on this sheet. We can see our elm trees in these circles here. Hope that's big enough that you can see that. Each circle is going to be marked off with a ring of decorative pavers. Okay, so they're going to surround the circle here with our little decorative pavers. I've seen things like that in backyards. In fact, I might have something like that in my backyard. And then to the nearest foot, how many feet of pavers will be needed to surround all 5 trees? To the nearest foot, how many feet of pavers will be needed to surround all 5 trees? Well, interesting question here, because the first thing you need to ask yourself is area or perimeter. And that might have been what threw poor Robin, because here we are on the area practice and I've mixed up the 2 concepts. Welcome to the GED. They love to mix up concepts. If I'm going around the elm tree, I am not going to cover that entire circle in bricks. I need room for the elm tree. I'm just going to go around the outside of the circles, meaning that I'm looking for the circumference of my circles. I'm going to put the bricks around. I'm looking for the circumference of my circle. I'm going to blow up this marking a little bit, actually. Let's blow it up nice and big so you can see that that elm tree is marked. It's marked with a little radius. See how those elm tree circles go from the center to the outside? It's a radius of 5. And 5 what? Well, our little scale here says we're in feet. So we have a circle with a radius of 5 feet. Okay, so now I know what I'm doing. I'm finding the circumference of a circle and I know its radius. So I am going to bust out the formula. C equals 2 pi r. And I'll plug in what I know. To find the circumference of the circle, I'm going to take 2, multiply by pi. I'll go ahead and use the decimal approximation by pi, and multiply by that radius of 5. And I should get 31.4. It's about 31.4 feet to go around one of those elm tree circles. But guess what? I don't only have one elm tree circle. Take a look at how many elms I'm planting. I'm planting 1, 2, 3, 4, 5. 5 elm trees, guys, means I'm going to have to make that same circle 5 times. So, and even here, the way I say it, 5 times, I'm going to need to take that 31.4 and times it by 5. So times that by 5 to get around all the circles, and I'm looking at 157 feet of pavers. All right, if you have any questions about this or any other GED math topic, be sure to drop it in the comments, and I will do my best to answer them.